Now let us see what are different types of Java programs. Java can be used to develop two types of programs, applications and applets. Java applications may consist of console programs, Windows programs, and other specialized applications. Let us look at some further details of these programs. Console programs are stand-alone text mode programs. These run under the control of local operating system on a console window like MS-DOS prompt or a Unix shell. Java Windows programs use graphical user interface such as MS Windows 95 or 98. In addition to these programs, there are also some other applications of Java like programming for electronic devices including telephones and VCRs. It can also be integrated with other languages to produce high-quality interactive applications. For example, integration with virtual reality modeling language to produce 3D interactive and virtual applications. Java applets are downloaded and executed inside a web browser. These are intelligent programs that can dynamically change according to user actions. Applets are referenced in web browser by an applet tag. Applets are assigned a particular area inside browser window, and these are not allowed to access the area outside of its allocated window area. This strengthens Java security. Dear learners, let me introduce you to Java and have a little look at its history and evolution. Java is a programming language developed by Sun Microsystems. First version of Java was released in January 1996. Before we start learning Java, let us see the reasons for its popularity. Java has a number of capabilities due to which it is considered powerful programming language. There are many other languages like C, C++, Visual C, Visual Basic, JavaScript, and JavaScript. But Java is considered most suitable programming choice, especially for Internet programming. Aforementioned languages can also be used to develop applications that are built in Java, but these languages have certain limitations like complexity of programming, platform independence limitations, lack of modern development features, for example, Internet development features, and programming of digital devices, loose security, non-object oriented development, and object-based programming. Java can be used to develop applications and interactive web pages. Here are some features of Java. These will be discussed in detail. You will also find implementation of some of these features during this course. Now, let us look at these features one by one. First and the most important feature of Java is its platform-independent nature. Java was aimed to be platform-independent and portable language that could be used on different CPUs. Platform independence is due to bytecode and Java Virtual Machine. What is bytecode? When a Java program is compiled, the output is in the form of bytecode. Bytecode is a set of instructions that are to be executed by Java Virtual Machine. Bytecode can be executed on a variety of platforms. While in other languages, program has to be recompiled for different machines. It is important to note that bytecode is not a self-executing code. JVM is required to execute it. What is Java Virtual Machine? It is an interpreter for bytecode. It provides runtime environment to execute bytecode. JVM differs from platform to platform, but all JVMs execute the same bytecode. For example, same bytecode can be executed on Microsoft Windows platform and Unix platform, but JVM specifications for both operating systems are different. Second feature of Java is architecture independence. As you know, technology is changing rapidly. Major changes are occurring in microprocessor technology, electronic devices, embedded systems, and operating systems. Java was developed by keeping all these aspects in mind. It can also be used for programming of wireless devices. The most important feature of Java programming is safety and security. There are always two types of risks when one is using internet: viruses and malicious programs. Viruses can wipe out all the data on your local machine. This is risky when you are downloading a page not developed in Java. ActiveX and stand-alone executables can access local file system. Malicious programs are intended to collect your personal information like passwords, credit card numbers that are saved on your local file system. Java applets are most secured for internet applications. Applets are downloaded and JVM executes the bytecode in a restricted and controlled execution area of web browser. It does not allow Java applets to access local file system. Another feature of Java is its speed. As compiled programs execute faster than interpreted programs, Java has both features of interpreter and compiler. When a program is downloaded on a client machine, JVM interprets the bytecode. This helps to execute programs that are downloaded at a slow speed. Java is capable of during the executions. Well, if you are familiar with object-oriented programming, then it's very easy to develop programs in Java. C programmers need very little effort to master Java. Elimination of pointers, address manipulation, and built-in memory management features further simplify Java. When we talk about Java's features, its one feature is Java is strongly typed. A strongly typed language is one that does not allow inappropriate data type conversions. It generates type conversion errors during program compilation, loading, and execution. Strong typing is necessary to achieve security and reliability. It restricts operations on Java objects that are explicitly defined in Java classes. One of the most important features of Java is object-oriented programming. Java is object-oriented. Java is completely object-oriented language and provides all features of object-oriented programming except multiple inheritance. Multiple inheritance is implemented with the help of interfaces. Object-oriented model of Java is very flexible and can be extended to new requirements. Robustness. Robustness can be achieved by overcoming program failures. Java programs execute as predicted in all platforms. Java checks and ensures consistency of programs at compile time and at runtime. Generally, there are two reasons for program failure: improper memory management and mishandled exceptions. In other languages, programmers have to allocate and deallocate dynamic memory. If a programmer fails to free memory that is not in use, it results in system overhead. It is also possible to free memory that is to be used by another part of program, resulting in system crash. Now we will find out how Java helps us to handle exceptions. Exceptions are error conditions that occur during program execution. For example, file not found, division by zero, accessing out of bound array index, etc. Now we will talk about Java threads. Java programs may have many threads. Threads are smallest pieces of dispatchable code. Threads can run concurrently. A single program can perform multiple tasks. For example, a word processing application can check spelling automatically and prints a document at the same time. Client-server applications can be developed in Java. Java 2 application program interface has features of remote method invocation and common object request broker architecture. RMI allows a Java object to communicate with the Java object running on another machine. Corba allows Java to communicate with applications other than Java applications. Java APIs are also used for window programming. Now let us discuss how we will develop graphics in Java. Java 2D API enables programmer to create graphics and graphical user interface easily. Java graphics are also platform independent and highly portable. Applets containing graphics can be distributed on the net and are executable on all Java platforms. Sun Microsystems provides Java Development Kit free of cost. It is available at http address www.java.sun.com. Presently, JDK 1.2 and JDK 1.3 is widely used. You can check for current version of JDK at Sun Microsystems website. Now we will learn using comments in Java programs. Comments are used in Java programs to make them more readable. Comments provide necessary information to the reader of program and help to understand the purpose of program statements. Comments are ignored by Java compiler. There are three types of comments in Java. These are single line comments, multi-line comments, and Java documentation comments. Single line comments start with double forward slashes. Anything written after these double forward slashes is ignored by Java compiler. You can also use. This program contains both single line and multi-line comment. Line 1 is a single line comment. Line 3 and 4 contain multi-line comments that start right after the class definition. You can put single line or multi-line comments as you can see in line 3 and 4. However, never enclose a program statement or component inside the comment. This will generate a compilation error. Note that at line 6 in multi-line 2 class, we have enclosed the closing brace of main method inside the comment. This causes a compilation error. The corrected program will look like this. Now the program will compile without generating any compilation errors. Java documentation comments are used for documentation purposes, and for simplicity we would not be using these commands in this course. Now we will discuss block of code. Java uses blocks of code to control visibility of variables and methods. A block of code starts with an opening curly brace and ends with a closing curly brace. Variables and methods defined within a block have certain attributes associated with them, for example, lifetime of variables and visibility of these variables or methods. Let us see a simple example. In this program, line 1 starts definition of block class and line 2 starts the body of block class that ends at line 4. Let us see another example. This program contains two blocks. First block starts at line 2 and ends at line 4. Second block starts at line 6 and ends at line 8. In this program, we have written comments in both blocks just for simplicity and explanation purpose. You can write any number of Java statements in these blocks. Now we will discuss life and scope of variables in a block. It is important to note that any variables defined in a block are visible in that block only, and these variables are destroyed when execution of that block is completed. This program contains three blocks. First block starts at line 3 and ends at line 14. Second block starts at line 5 and ends at line 13. Third block starts at line 7 and ends at line 10. At line 6, we have declared an integer variable. This is visible to all the code that is written after this line. The variable is not destroyed until main method completes its execution at line 13. At line 8, a float variable has been declared. Since this is inside the block that starts at line 7 and ends at line 10, and as this block is exited at line 10, this variable is destroyed. If you remove the double forward slashes of line 12, the program will generate a compilation error because you are trying to access a variable that has been destroyed when its block was exited at line 10. Now we will discuss a simple Java program in detail. This is a Java console application. Its purpose is to print a welcome message. Before we learn how to compile and execute this program, let us discuss it in detail. This program consists of line numbers, comments, Java keyword, and some Java statements. Line numbers are not part of Java program, but these are used for our discussion and reference purposes. Some special symbols like curly braces, square braces, semicolon, and comma are used in this program. These have special purpose. For example, semicolon is used in Java to terminate Java statements, and braces are used to create blocks of codes. Line 1 is a single line comment. It begins with the double forward slashes. These indicate that a remainder of this line is a comment. Comments make your program more readable and help to understand purpose of program statements. It is recommended that when you start writing code, you must use comments. Comments are ignored by the compiler. Line 2 is blank. Blank spaces are called white spaces and ignored by Java compiler. Line 3 begins with the class definition. Class is a keyword that is used to create a class. We will learn classes in detail in Unit 5. Class is a template for creating objects. Keywords have special meaning for Java compiler. The body of class starts at line 4 and closes at line 9. Welcome is name of class defined by programmer. Programmer-defined words in Java are called identifiers. Identifiers are defined by the programmer. Identifier name can only consist of alphabets, digits, underscores, and $sign. Identifier must not begin with the digit. Spaces are not allowed in identifier names. Java is strictly case sensitive, that is, uppercase and lowercase alphabets are treated differently. For example, welcome, welcome, and welcome are three different identifiers. Line 5 begins with main method. Every Java application automatically starts execution from main method. Java application must contain main method, but applet does not require main method. Methods perform a specific task and may return a value. Method names are preceded by we will learn how to install Java Development Kit in Windows environment. You can download JDK 1.2, JDK 1.3 for free from www.java.sun.com. These are also available on CDs available in the market. We have used JDK 1.3 to compile and execute programs. After you download or get JDK from some CD, double-click on the executable file of J2 SDK 1.30 in the Windows Explorer. It is a self-extracting program that installs Java. Follow the instructions to complete the installation and specify a destination folder, for example, C:\JDK 1.3. After the setup is complete, load Run command in the Start menu of the Windows operating system taskbar and type sysedit. Add C:\JDK 1.3 \bin at the end of path command in autoexec batch file. Load ms-dos prompt and execute autoexec bat by typing at command prompt. Now the path command may look like this. Now we will learn how to write and save Java programs. You can write Java programs in any text editor, for example, Notepad. After writing the program in Notepad, select File menu and choose Save As option. In file name, type welcome.java and in Save As type, select All Files option, then press Save button. Now we will learn how to compile and execute Java program. Before you compile Java program, you must be in the folder where you have saved welcome file. Write this command at command prompt to compile the Java program javac followed by welcome class name and Java extension. This will generate a class file with the same name as Java source file, that is welcome.class. When this file is compiled, type Java followed by name of the class file without extension to execute the class file. This will execute the program and print hello, welcome to Java. In this unit, we will learn basic data types, variables and arrays. We will also discuss primitive data types like byte, short, int, long, char, float, double, and boolean. We will create and discuss different types of variables and arrays. Write programs to search arrays and learn references and reference parameters. After completing this unit, you will be able to understand primitive data types used in Java, their size and range of acceptable values. Different types of variables, one-dimensional and multidimensional arrays, strongly typed nature of Java, searching arrays for different data types, references and reference parameters. Let us start with our first topic, primitive data types in Java. There are 8 primitive or simple data types in Java. These are grouped into integral data types, floating point data types, character data types, and Boolean data types. Integral data types are used to hold signed positive and negative whole numbers. These contain byte, short, int, and long. The difference between these data types is the amount of storage and the range of values that they can store. These are further discussed in the subsections. Floating point data types can hold whole numbers as well as fractional numbers. There are 2 floating types, float and double. Floating point numbers are also called real numbers. These are further discussed in the subsections. Character data types is used to store letters and numbers in Unicode format. For example, char ch declares a variable of character data type. All these data types are further discussed in the subsections. Boolean data type is declared by Boolean keyword. Boolean variable can store true or false value. Simple data types are used to represent single values but not objects. Java also defines integer, float, string, and Boolean classes. These are called wrapper classes. This list shows wrapper classes for each simple data type. These classes wrap or encapsulate simple data types in a class object. These constructors show how wrapper classes wrap simple data type. We will discuss constructors in detail when we will discuss classes. Here are some examples of constructors. Now we will discuss each primitive data type in detail. Let us start with byte. This is the smallest integral data type. It can store signed whole numbers. It uses 8 bits to represent a value. The range of values it can contain is from -128 to +127. Byte variables are declared by using byte keyword. For example, byte b declares a byte variable b. Let us see a simple program that demonstrates strongly typed nature of Java. This program will generate compilation error at line number 12. In the statement b equal to b plus 3, 2 operands on right side are byte and integer. Java makes calculations on integers. Here 3 is integer but b is byte, and the result is an integer when we try to assign this value to b. An error is generated for possible loss of precision. This is because of strongly typed nature of Java. To correct this error, replace statement with now the result of b plus 3 will be an integer value, that is 123, and it will be converted into byte and then stored in b on left side. Braces are important here. Next integral data type is short. Short variable can store signed positive and negative whole numbers. The size of short variable is 16 bits. A short variable can store values in the range from -32768 to 32767. It is mostly used in those machines that support 16-bit word size. Word size is the amount of bits that are fetched and processed by a CPU at a unit of time, for example, a microsecond. 8386 microprocessor was 16-bit processor. In this program, we have declared a short variable at line 7 and assigned initial value of 32767. This is the maximum value that a short variable can store. At line 8, we have used a post increment operator that adds 1 to short variable s. Arithmetically, the value of short must become plus 32768, but it is minus 32768. This is due to range of short variable because a short variable can hold values only in its range. In this program, line 8 would not work and generate a compilation error. The correction is made in line 9. At line 9 of this program, addition is performed by converting the numbers into integers, and the result exceeds the valid range of short. So we have to convert the resulting integer back to short. This is done by casting. General form of casting is like shown in this figure. Here, target variable will hold the result of the expression. Data type is the type in which the result of expression is to be converted. Data type is the type of target variable. Next integral data type is int. Int is commonly used data type to store signed whole numbers. It occupies 32 bits. The range of values stored in an integer is from -2 power 32 to 2 power 32 minus 1. Integer variables are used to control repetitive loops and can be used as indexes in array operations. Java uses integers to make calculations. If you are using short or byte variables for calculations, Java promotes these types into int internally. For example, look at this example. You have to explicitly convert the integer 5 resulting from the second statement. Last of integral data types is long. It is the largest of all integral data type. The size of long is 64 bits. The range of values that can be stored in long variables is from -2 power 64 to 2 power 64 minus 1. It can hold signed whole numbers. Long is used in computations where very large numbers are required. Finally, let us see the behavior of integral data types in arrays. In arrays, the behavior of byte, short, and int is predictable. Byte uses only 1 byte per array element. Short uses 2 bytes per array element, and int use 4 bytes per array element. Java runtime environment uses the size of a variable as required by the computer in use. Some implementation of Java virtual machine store byte and short variables as 32 bits rather than actual size of 8 bits and 16 bits. Next category of data types is floating point data types. There are 2 floating point data types in Java, that is float and double. Both of these types are used to hold signed numbers with fractional part, but they differ in amount of storage. These are also known as real numbers. These are used in calculations such as scientific and mathematical functions like sine, cosine, and square root. Now we will discuss each of floating data types in detail. First floating point data type is float. Float is used to hold signed numbers with fractional part, for example 2.0 and 13.57. It specifies a single precision value. Single precision values consume less space on machine and are faster than double precision values. Float becomes imprecise when the number is very small or very large. Float variables are used when you are using fractional numbers but not need a high degree of accuracy. For example, floats is useful when you are representing currency like Pak rupees and US dollars. Float variables can be used for tax and pay calculations. Second floating point data type is double. This is used to represent very small or very large fractional numbers. It requires 64 bits to store a number. It is faster than single precision on some computers that perform optimized mathematical calculations. Double has the highest accuracy when you are using very large or very small fractional numbers. It is important to note that all mathematical functions like sine, cos, and square root return double values. Double maintains accuracy in looping and iterative calculations. Next category of data type is character data type. It has only one data type, that is char. Characters are stored in variables of char data type. Char data type can hold only single character. Java uses Unicode to represent characters in Unicode format. Any character in the human languages like Arabic, Greek, Latin can be represented in Unicode. It requires 16 bits to represent a single character. The range of char is 0 to 65536. The range of ASCII characters is from 0 to 127 and ABCDIC is from 0 to 255, but Java can handle Unicode characters in the range of 0 to 65536. Characters of English, German, Spanish, and French can be stored within 8 bits range. Here is a declaration and an assignment statement that declares a character variable and assigns a value to it. Arithmetic operators can be applied on character variables, and these behave like integer arithmetic. For example, look at these two statements. First statement stores a character to ch, and second statement increments the value of ch. You can assign a whole number to a character variable. Java will treat it as ASCII or Unicode value. For example, this statement stores a in ch. To assign character value to character variables, enclose it in single quote. Only one symbol can be stored in a character variable. Now we will discuss a few programming examples. At line 5 of this program, we have declared two character variables C1 and C2. At line 6, C1 is assigned ASCII value. This is ASCII code for alphabet A. At line 7, we have assigned character B to C2. You can assign only single letter to a character variable. Line 8 and 9 print the values stored in these variables. In this program, the arithmetic statement is different from those of unary pre, post, increment operator and addition assignment operator. At line 8, the arithmetic statement is adding a character variable and an integer. Java performs arithmetic operations in integers. It converts ch into integer before adding 10 to it. The resulting value is an integer. This needs to be converted back to character. This is done by using cast operator that converts the result into target data type. In this case, we used char to convert the result into character and assigned the result to character variable ch. The last data type in this topic is Boolean data type. Logical values are stored in Boolean data type variables. There are only two Boolean values, true or false. Boolean data type is used in conditional expressions like if, for, and do while. All relational operators return true or false value. Now let us discuss a program that demonstrates the use of Boolean value true. At line 5, if conditional statements tests a Boolean value. Since this is true, the statement at line 6 is executed. We will discuss control structures including if later in detail. For simplicity, remember that if the condition in if statement at line 5 returns true, only then the next statement is executed. General form of if condition is, another general form of if is. Here, if condition is true, then both statement 1 and statement 2 will be executed. You may add many statements in this block. Now let us see the program that demonstrates the use of Boolean false value. When Java conditional statement returns a false value at line 5, the statement at line 6 is not executed and nothing is printed. Now let us see another program that uses a relational expression and returns a Boolean value. At line 5, a relational expression is given as an argument to print method. Since the number 10 is greater than 9 and this relational expression returns true Boolean value, this program will print true. It is important to note that only Boolean values true and false are sufficient to control if, while, and do-while statements. Now we will discuss literal values used in Java. Constant values are called literals in Java. Java contains 4 types of literals. These are integer literals, floating point literals, Boolean literals, and character literals. Integer literals are whole number values are integer literals. Java has decimal, octal, and hexadecimal integer literals. This picture shows some literals. Floating point literals represent decimal values with fractional component. These are represented in standard or scientific notation. For example, 3.0, 3.14159, 0.668 represent valid standard notation. These can also be written in scientific notations. Floating point literals in Java have double precision. Capital F or small f is appended in the last of the constant to specify a float literal. Float type needs 32 bits while double needs 64 bits. To specify a double literal, append capital D or small d to the constant. Next type of literals are Boolean literals. These can have only 2 logical values, that is true or false. True value is not equal to numerical value 1 and false is not equal to number 0. True and false values can be assigned to variables declared as Boolean. True and false are case sensitive and true or false are not logical values in Java. Java also contains character literals. Character literal is enclosed inside single quotes. It requires 16-bit storage. Escape sequences can be used to write special character literals. This table shows some escape sequence characters, their purpose and print statements that can be used to print these escape sequences. Last type of literals are string literals. String literals are enclosed in double quotes. All escape sequences defined for character literals also work for string literals. Strings are treated as objects in Java. Do not split strings on multiple lines because there is no continuation character in Java. This table shows some string literals, Java statements, and their output. Now we will discuss arrays. Collection of similar data types is called an array. Arrays can be single-dimensional or multi-dimensional. Single-dimensional arrays are like linear lists. Multi-dimensional arrays are like matrix. Each array has a unique name and array index to access each value stored in array elements. Array index is an integer number like 0, 1, 2, 3, 4, and so on. Arrays can be used to store simple data types like integers, floating point numbers, character constants, or objects. To store a value, you have to create an array of that data type. If you want to store integer values, you have to create an array of int data type. To store real numbers, you need to create an array of float data type, and similarly, char array for characters. To store objects, you have to create an array of that data type. Now let us discuss one-dimensional arrays in detail. A one-dimensional array is a linear list of similar type of variables. Creating an array involves 2 steps. First step is to declare an array, and second step is to allocate memory to store elements in that array. General form of declaring a one-dimensional array is data type followed by array name and set square brackets. Here, Data type specifies the type of values that are to be stored in the array. It can be a primitive data type like char, int, byte, float, or some object type, for example, string. Here, array name is a user-defined name that follows naming rules in Java. Next step is to allocate memory for this array. General form to allocate memory for this array is, here size is the size of array. It specifies total number of elements that this array will contain. This must be a whole number. The keyword new is used to allocate memory dynamically. These two statements can be combined into one like this. One-dimensional arrays can also be created by using this general form. Arrays can be automatically created without using new keyword. The general form to create arrays automatically is. Now let us discuss a one-dimensional array named array name. This figure shows an integer array that contains 3 integer values. These are stored at neighboring memory locations. Each element can be accessed by using array name followed by index value in square brackets. For example, the value at index 2 is 6435. This is accessed by name of array followed by 2 enclosed in the square braces. Let us see a simple program that creates an array and uses for repetition loop to print the contents of this array. Line 6 declares an integer variable that will be used to store array index. Line 7 starts with string class name and declares an array of strings named names. This array contains 3 names, Ahmed, Saba, and Mona. Line 10 starts with a for loop. For loop will be discussed in detail when we will discuss repetition control structures in Unit 3. The general form of for loop is for keyword followed by left space, followed by comma, separated initialization statement, condition, iteration statement, followed by closing brace, followed by a statement or block of statements. Let us see the for loop execution step by step. In the first step, when for loop starts execution, the initialization statement is executed, and it initializes the repetition control variable. In this example, we are using I as a repetition control variable, and it is initialized to 0. I is initialized to 0 because array indexes start from 0. In second step, the condition is evaluated. This condition returns a true or false value. The condition tests the loop control variable against a target value. In this example, we are testing it against 2, and now the value of I is 0, and the condition expression will return true. Third step is to execute the body of loop if the condition is true. Since the condition is true, line 11 will print the value stored at 0 location of names array. When the condition expression returns false, the loop terminates. In the next step, after executing line 11, the control moves to line 10 at iteration portion, that is I++. This expression adds 1 to the value of I, and now value of I is 1. The condition is evaluated again. In this case, it will test 1 is less than or equal to 2. The condition expression returns true, and the statement at line 11 is executed again. The control moves to iteration statement at line 10, that is I++. The value in the control variable I becomes 2. The condition is tested again. Since it is true, the statement at line 11 is executed. Again, the control moves to iteration statement at line 10. Now the value of I is 3 and condition becomes false and loop terminates. There are no more statements in the program, so program terminates successfully. Conceptually, this array will be stored in memory as shown in this figure. Now let's talk about how Java ensures boundary checks of an array during program execution. At runtime, Java checks that the program does not access array elements that are out of bound of array index. If index value is out of valid range of array size, then an error is generated at runtime. Last line in this output shows the error message that will be generated at runtime. This is because of accessing array element that is out of bound. Valid array indexes are names 0, names 1, names 2. This program tries to access names 3, that is invalid, so exception or error occurs. The error message also shows line number of the code that has generated the error. Now we will learn references and reference parameters. Two ways to pass an argument to a method are call by value and call by reference. Other languages allow you to choose between call by value or call by reference, but Java does not allow to do so. In Java, all primitive or simple data type variables are passed by value and all objects are passed by reference. That is, a reference to an object is passed to the called method. It is important to understand the difference between both call by value and call by reference. Here is a comparison. In call by value, simple data type variables are passed by value. In call by reference, reference to object is passed. In call by value, a copy of the variable is made and sent to the called method. In call by reference, reference to the object is sent to the called method instead of a new copy of the object argument. In call by value, changes made to the parameter in the called method do not affect actual variable. In call by reference, changes will affect the source object because its reference points to same memory location even in the called method. Since a new copy is created, system resources are required to make, and this is an overhead in case of large number of parameter passing. Arrays are treated as objects in Java, and reference to the array is passed to the called method. This does not use much resource of system. Primitive data types are always returned by value. Objects are always returned by reference. Let us see a simple example that illustrates argument passing. This program defines two classes. Line 1 starts with the definition of my class and line 15 starts with the definition of by reference class. The program starts execution from line 19 and creates an object of my class. The values passed in the constructor of my class are 10 and 20. These are integer literals and are passed by value. The constructor at line 4 creates the object and assigns these values to the instance variables of objActual. Line 20 prints the values of these instance variables. These are 10 and 20. Line 21 calls willChange method and passes the reference of the object in the method call. At line 9, willChange receives the reference in the object obj of my class type. Inside the method, both instance variables are incremented by 2. Since there are no more statements in these method and control is transferred to line 22 right after the call to method, this line prints the values of instance variables. Now see that the values of actual object have changed. This is because Java always passes objects by reference, and any changes made to them in called method will directly affect the actual object. Now we will learn searching arrays. You can search for a specific item in an array. Searching involves comparing the required item with all the values in the array. For example, if we have an integer array containing 10 values as given in this figure, and we want to search 690 in this array and print the position of that element, then we have to compare each value in the array elements with 690. Now let us see the program that completes this task. This program declares an integer array that contains 10 numbers. Line 7 declares an integer variable that will control for loop, and we will use its value as array index. Line 8 declares a boolean variable that contains false value. This variable tells us that the search is not successful yet, and if the number is found in the array, it will be assigned a true boolean value at line 14. Line 9 declares a variable that holds the number to be searched in this array. Line 10 contains a for statement that repeats the block of code starting at line 11 for 10 times. If statement at line 12 compares value in each array element with the number in the search item, that is 690. If the number in the array matches with the number stored in search item, it executes the block of code starting from line 13. Inside this block, break statement is used. When a break statement is encountered in a for loop, the loop is terminated and the control moves to the statement written immediately after the block. In this program, the value is found in the array at position 5, so the block of code is executed and the message is printed. And then break statement terminates the for loop and control moves to line 19. If the element is found, the variable found contains true value. Line 19 uses an if statement that applies a not operator on boolean variable. This operator reverses the value stored in the boolean variable. That is, if the boolean variable contains a true, then this statement will reverse it to false and the statement at line 20 would not be executed. If the value of found variable is false, the not operator in line 19 reverses the value of found to true, and the statement at line 20 is executed and displays the message. In this program, the array defined at line 6 contains the number 690, so the statement at line 14 assigns true value to boolean variable found, and when line 19 is executed, the if condition evaluates to false and line 20 is not executed. Now we will discuss multidimensional arrays. These are arrays of arrays. Conceptually, these look like matrices, but these can have uneven shapes. General form to declare a two-dimensional array is data type followed by 2D, array name, and square brackets terminated by semicolon. To assign physical memory, we use this form. Here, data type can be basic data type or some object data type. Row specifies total number of rows in the array. Column specifies total number of columns in the array. These statements can be combined into one statement like given in this picture. This statement created a matrix that contains 3 rows and 2 columns. Now let us see conceptual representation of different arrays in memory. This picture shows a conceptual diagram of two-dimensional array that has 3 rows and 2 columns. Left indexes are row index and right index are column indexes. Element of this 2D array can be accessed by specifying the name of array and the index position. This is an odd-shaped array. First row contains 1 column, second row contains 2 columns, and third row contains 3 columns. Array names and index positions given in this picture can be used to access specific array element. Let us discuss a simple program that manipulates a two-dimensional row. This program declares a two-dimensional array, assigns values to each element of array, and then prints the contents of this array. Line 6 declares an array that will contain character values. The name of array is 2D. It has 4 rows and 5 columns. Line 7 declares 2 integer variables that will be used to control loop, and these will also help us to store index position of array elements. By using these variables, we will access individual elements of the array. Line 8 declares and initializes a character variable with the character A. Line 9 is a nested for statement. For statement at line 9 controls the row index of the array, and the for statement at line 10 controls the column index of the array. The for loop at line 10 has a block of code that contains two statements. Line 12 assigns the value stored in character variable C to array elements. Line 13 uses post increment operator to store ASCII code for next character in the variable C. The for loop at line 9 executes 4 times, and each time the inner loop at line 10 executes for 5 times. These iterations may conceptually look like this. The for loop at line 9 repeats the statement for 4 times, and when the value of I is 4, the condition in for loop at line 9 returns false. Due to this, for loop terminates. Now we will discuss multidimensional arrays. These are arrays of arrays. Conceptually, these look like matrices, but these can have uneven shapes. General form to declare a two-dimensional array is data type followed by 2D, array name, and square brackets terminated by semicolon. To assign physical memory, we use this form. Here, data type can be basic data type or some object data type. Row specifies total number of rows in the array. Column specifies total number of columns in the array. These statements can be combined into one statement like given in this picture. This statement created a matrix that contains 3 rows and 2 columns. Now let us see conceptual representation of different arrays in memory. This picture shows a conceptual diagram of two-dimensional array that has 3 rows and 2 columns. Left indexes are row index and right index are column indexes. Element of this 2D array can be accessed by specifying the name of array and the index position. This is an odd-shaped array. First row contains 1 column, second row contains 2 columns, and third row contains 3 columns. Array names and index positions given in this picture can be used to access specific array element. Let us discuss a simple program that manipulates a two-dimensional row. This program declares a two-dimensional array, assigns values to each element of array, and then prints the contents of this array. Line 6 declares an array that will contain character values. The name of array is 2D. It has 4 rows and 5 columns. Line 7 declares 2 integer variables that will be used to control loop, and these will also help us to store index position of array elements. By using these variables, we will access individual elements of the array. Line 8 declares and initializes a character variable with the character A. Line 9 is a nested for statement. For statement at line 9 controls the row index of the array, and the for statement at line 10 controls the column index of the array. The for loop at line 10 has a block of code that contains 2 statements. Line 12 assigns the value stored in character variable C to array elements. Line 13 uses post increment operator to store ASCII code for next character in the variable C. The for loop at line 9 executes 4 times, and each time the inner loop at line 10 executes for 5 times. These iterations may conceptually look like this. The for loop at line 9 repeats the statement for 4 times, and when the value of I is 4, the condition in for loop at line 9 returns false. Due to this, for loop terminates. And next statement at line 15 is executed. Line 15 is also a nested for loop, and it has more than one statements in the block that starts at line 16 and ends at line 20. It is important to note that each time inner for loop at line 17 completes, the statement at line 19 is executed once, because this is enclosed in the block of for loop that starts at line 15. In this unit, you will learn control structures. You will learn how control structures control the execution of Java statements. You will also learn Java selection statement and while repetition structure. We will write some programs to illustrate the use of control statements. After completing this unit, you will be able to understand what is a control structure, understand normal program execution, understand conditional program execution, write programs using conditional statements, write programs using Java selection and iteration statements. Before writing a computer program, you must decide the sequence in which the instructions will be executed. The instructions may be executed in three different ways. That is, in linear fashion, that is from top to bottom. Specific instructions may be executed depending on some condition, or instructions may be executed repeatedly. Java provides three control structures that control the execution of program instructions. These selection structures are sequence control, selection structure, and repetition structure. Selection structure includes if else, and switch statements. Repetition structure include while, do while, and for statements. Now we will see how sequence control structure works. In sequence control structure, the instructions are executed in the sequence in which they are written in the program. That is from top to bottom. Let us see how this program executes the instructions. When the program starts execution, line 1 is executed first, then line 2, and so on. Nothing is visible to the user since lines 1 to 4 do not have any output statements. Line 5 and 6 are executed in the sequence in which they are written, and the word hello is printed first and the word there is printed next. Java's control statements are nearly identical to C, C++, but there are certain differences, especially in the break and continue statements. Now we will discuss selection statements in detail. Selection control statements allow the program to choose different paths of execution based on an expression or the Boolean variable. There are two selection statements in Java that are if and switch. These statements allow you to control the flow of your program execution based on conditions known only during runtime. Let us briefly look at the if statement. The if statement is Java's conditional branch statement. If statement can be used to select a path from two sets of statements. General form of if statement is if keyword followed by condition inside the braces followed by a single statement. Statement is executed if the condition is true. Another general form of if with else part is if keyword followed by condition inside the braces followed by single statement, else keyword, and a single statement. If you want to execute more statements, then you have to enclose them in curly braces. This may look like shown in this figure. The condition is any expression that returns a Boolean true or false value. In if statement, else clause is optional. Now let us see how if condition works. If the condition is true, then statements in the block that is written after if statement and before the else statements are executed. Otherwise, the statements that are written in block after else keyword are executed. Both blocks of statements are not executed in any case. Let us discuss if statement with an example. This program segment contains three statements. Line 1 declares two integer variables and assigns values to these variables. Line 3 contains if statement that evaluates the conditional expression a is less than b. Since the value stored in variable a is less than b, this conditional expression returns true, and line 3 prints the message enclosed in the quotes. Let us see another example that has three statements after if statement. Since these are not written in the block, Java follows if condition structure and executes line 3 when the conditional expressions at line 2 returns true. It will always execute line 4 and 5 even if the conditional expression at line 2 returns false value. Now let us start discussion for iteration statements. Iteration control structures repeat one or more statements. For, while and do while are iteration control structures of Java. The first iteration control structure in our discussion is while repetition structure. It repeats a statement or block of statements while the control condition is true. General form of while is while keyword followed by condition in braces, that is followed by a block which contains statements that are to be executed when control enters the block. While loop is useful when you have to repeat statements for an unspecified number of times. The while repetition statement executes the block only if the condition is initially true. When condition becomes false, control passes to the next line immediately after the block. Let us see a simple program that illustrates a while loop. Line 5 of this program declares an integer variable num. This will be used to control while repetition statement. The conditional expression on line 6 compares the value of num with 0, and if it evaluates to true, it will execute the block from line 7 to line 10. Inside the block, num is decremented by 1 each time and the control is transferred to line 6. This process continues until the conditional expression at line 6 becomes false. And when the condition at line 6 becomes false, the program terminates. Let us see another program that demonstrates infinite nature of while loop. This program will not terminate and print true for infinite number of times. You will have to terminate it forcefully. Now we will discuss for looping structure. For loop is used to repeat statements for a known number of times. General form of for is for keyword followed by initialization statement, control condition and iteration expression inside the braces. Next line may be a single statement or a block of statements. Let us see a simple example that demonstrates the use of for loop. This program prints the result as shown in the output. When the loop starts, initialization statement is executed. This is executed once. It sets the value of control variable I to 0. Then the Boolean condition is evaluated by comparing value of I with 5. Since 0 is less than 5, the body of 4 is executed. Then the control transfers to iteration expression. It increments the value of I by 1. Next, the control condition evaluates the condition, that is, I is less than or equal to 5. If it evaluates to Boolean value true, the block of code is executed. This process continues, and when the conditional expression returns false, the for loop terminates. Now let us discuss do while repetition control structure. Do while repetition structure becomes useful when you want to execute statements before a condition is checked. In do while repetition structure, the statements given in the do while block are executed at least once, even if the condition is false, because the condition is tested at the end of block of statements. The general form of do while loop is do keyword followed by set of curly braces that contain one or more statements. After this block of curly braces, while keyword and the condition is written. Let us see a simple example that demonstrates the use of do while. In this program, we have declared a Boolean variable b and assigned it false value. The do while loop will execute the statement at line 8 and terminates when it evaluates the condition at line 9. Note that condition is false, even then the statement at line 8 is executed once. Look at this program. It will print numbers from 1 to 5. Now let us discuss break statement. Break statement can be used to exit from any block of code or terminate any control structure. The general form of break is break followed by semicolon. Let us see a simple example that uses break statement. If we remove the break statement at line 8, this program will repeat for infinite time. The break statement terminates the while loop at line 8 and it is executed only once. Let us see another example. When the value of I is 3 in the for loop, the loop terminates at line 10. The program stops execution since there are no more statements after for loop. Continue statement. It can be used to force an early iteration or repetition of a loop. Continue statement can also be used to skip some statements in particular situations. In while and do while loops, continue statements transfers control to the conditional expression, and in for loop control is transferred to iteration portion and then to conditional expression. Let us see how continue statement is used in a for loop. This program prints 15 numbers. Each line contains 2 numbers in the output. Line 8 uses modulus operator. It divides the value of I by 2, and if the remainder is 0, that is, the number is even, then it returns true. And the control is transferred to iteration statement, that is I++ at line 5. And the statement on line 10 is skipped. This causes an early iteration of the for loop. Now we will discuss switch selection structure. Switch structures can be used to execute statements based on many values of an expression. General form of switch statement is as shown in this figure. Switch keyword followed by expression in the braces and the block containing many case keywords followed by literal values and an optional default case. Each case block contains single statement or statements and a break statement. The value 1, value 2 must be compatible with the expression. That is, both the value and argument passed to the condition must have same data type. Each value must be a unique literal constant. Variables are not allowed. The expression must be byte, short, int or char. Now let us discuss how switch statement works. The value of the expression is compared with each of the literal values in the case statements. If a match is found, the code following the case statement is executed. If none of the constants match the value of expression, then the default statement is executed. Default statement is optional. When break encounters the switch, block terminates execution and branches to the first line after the switch block. The break statement is optional. If you omit the break statement, execution will continue on the next case. Sometimes break statement is placed after many case statements. Now let us see a program that contains a switch statement. Line 5 of this program starts a for loop that repeats the switch statement for 4 times. This program uses a simple switch statement at line 6. When the statement at line 5 is executed, the initial value of I is received in the switch statement at line 6. This value is compared with the value given after case statement at line 8. Since both values match, the statement at line 9 and 10 are executed. Break statement will terminate the switch block and control moves back to I++ in for loop. Now the value of I is 1 and it is passed to I in switch statement. This value is compared with the value given after case statement at line 8. Since 0 is not equal to 1, so the next case statement is tested. And at line 11 the match is found. The statement then on line 12 and 13 are executed. This process continues until the conditional expression in for loop returns a false value. When the value of I becomes 3, there is no match for literal 3 in any case statement inside the switch block. At this time, default case is executed. There is no need of break statement in the default case. It is important to note that switch, case and break are Java keywords and these must be written in small letters. We can also use nested switch statements. Its general form is as shown in this figure. Now let us briefly look at the differences between if and switch statements. Switch statement can only test for equality, whereas if can evaluate any type of expression that returns a true or false value. Two case constants cannot have identical values. A switch statement is more efficient than nested if statement. Switch can be used for a large number of values, while if can only test true or false Boolean values. The basic component of object-oriented programming language is a class. Now let us see what is a Java class. A class is a template for an object, and an object is an instance of a class. A class can contain data members and methods or functions that operate on these data members. A class may contain only data or only methods. Class keyword is used to declare and create a class. Access controls are used to control the access to instance variables and methods of class. Java uses access specifiers in the declaration part to allow access of a member. There are three access specifiers in Java, that is, public, private, and protected. This table summarizes three access specifiers. In this class, credit card number instance variable is private, so only public methods defined within this class can access this number. You cannot even view or display the value of private instance variable since this class does not provide any method to display the value of credit card number. This is also an example for encapsulation of data and methods in a class. This feature of object-oriented programming provides the programmer complete control, and programmer can restrict the access to data using encapsulation. Now we will learn how to create packages. Classes created so far were using same namespace that had no name. Java allows you to organize classes into packages that represent folders on your hard disk. You can create a package by simply providing package command as the first line in your program. The general form to create a package is package keyword followed by package name and terminated by a semicolon. Here, package is the name of package. Java uses local file system to store packages. Now let us see a simple example. Suppose you are working in the folder e:\java work. Then create a folder my package in this folder and save test.java in my package folder. Compile the Java file. The class file must be in my package folder now. To execute a file inside a package, the execution command is a bit different. In this case, it will look like this. Now let us see constructors. Constructor is a special method. You can create your own constructors. When defining a class, constructor is used to initialize object when they are created. If you do not specify a constructor in a class, Java creates a default constructor for that class. It is important to remember that class name and constructor name must be the same. This class does not contain any constructor, but Java creates a default constructor for this class. Constructor has no return type. Implicit return type is class type. This program shows a constructor with parameters. The constructor of this box class is more generalized, and you can create objects by providing different values for different objects. When an object is created, you can specify arguments that will be used to initialize the instance variables of the object. First two statements in main method create two box objects with different parameters. Last four print statements print the volume of both box objects. Note that the instance variables are accessed by object name followed by dot operator and the instance variable name. Now let us discuss methods. A class contains instance variables and methods that operate on these instance variables. Method can have a single statement or a set of statements that perform a specific task. Methods may or may not return a value to the calling program. If a method has no return type, then you must specify void as return type. This method returns a float value. Here, the return type void shows that this method will not return anything. Now we will learn get and set methods. The car class defines two methods that are setColor and getColor. The return type of both methods is void. Class car demo creates an object of car class. The default constructor of car class creates the object and assigns null value to it. The setColor method is used to set the color of instance variable of myCar object. Get method at line 19 prints the value of instance variable. The program finishes because there are no more statements. Now we will see how to use this keyword. When you define a method in a class, you can use this keyword to refer to the object of the class in which this method is defined. Although it seems redundant because instance variables can be accessed directly by methods of the same class, but it is helpful in situations when local variables that are given in the parameter list of that method hide instance variables. When instance variables and local variables of a method have same name, then use of this keyword accesses instance variables of the object on which the method is called. In this program, the names of instance variables and parameters are same, that is hours, minutes and seconds. In this case, this variable is very helpful. At line 8, 9 and 10, this dot hours, this dot minutes, this dot seconds are the instance variables of the object that has called the method, and hours, minutes and seconds are variables that are received as a parameter. Now we look at garbage collection and finalize method. When we create an object by using new keyword, memory is allocated dynamically. An object is physically created. You have seen that we never reclaimed memory from the system. This is because of Java's garbage collection subsystem. Java automatically destroys an object when there is no reference to that object. This frees the programmer to remember and write code for necessary deletion of objects that are not in use during runtime. It also eliminates the risks of accidentally removing objects that may be required by the program. Sometimes programmers use objects to hold resources like file handlers and local operating system fonts. You must ensure that these resources are released before Java objects are destroyed. Java provides finalize method to accomplish such destruction tasks. This method can be used to specify actions that will occur just before destruction of objects. Now we will discuss static members. So far, we have seen that data members and methods of a class can only be accessed by using object of that class, a dot operator, followed by the name of class member. Static members can also be accessed without declaring an object of that class. Static members are declared by using static keyword. Both instance variables and methods can be declared as static. Now we will discuss static variables. In this program, we have declared an instance variable at line 3. The name of instance variable is local. At line 4, we have declared and initialized a static variable a. Initialized it to 10. Line 5 declares another static variable b. Line 6 starts with static block. This block contains two statements. The statement at line 8 is commented because it is illegal to refer to instance variable in a static block. If you uncomment line 8, it will generate compilation error. Static block is used to initialize static variables. Line 16 and 17 print the value of static variables. Line 18 is commented because it will generate compilation error. Non-static variables cannot be accessed in main method. Now we will discuss static methods. Static methods are declared by using static keyword. We have been using main method in our programming examples. It is a static method and is used before any object of that class is created. Static methods can only call other static methods, can only access static data, cannot use this or super keywords. This example demonstrates a static method. Line 5 declares a static method. This method is called in main method at line 16. Static methods can be called without object and by using their class name. Now we will discuss superclass. An object of one class is an object of another class. For example, a manager is an employee, a programmer is another employee, and a secretary is also an employee. The manager, programmer, and secretary employee classes can be said to inherit properties from employee class. The employee class is then called a superclass, and manager, programmer, and secretary employees are called subclasses of superclass employee. Superclasses are more generalized classes. For example, a student class is generalized form of class, while graduate student and undergraduate student classes are more specialized subclasses. Superclass define instance variables and methods that are available to all subclasses. Now we will discuss subclass. Subclass is the class that inherits properties from its superclass. For example, a car class is a subclass of vehicle superclass. Subclass can override or redefine the methods defined in superclass accordingly. This is helpful when a subclass inherits methods that it does not need to or should not have inherited. For example, the salary calculation method for a manager is different from that of a normal employee, and you have to override the method in manager subclass. Now we will discuss protected members. Subclass can access public and protected members of its superclass inside the same package. The methods in subclass can normally access public and protected members by using the name of method. When a subclass method redefines or overrides a superclass method, the superclass method can be accessed by super keyword and method name. Inheritance. Inheritance is one of the most important features of object-oriented programming. Inheritance allows you to create reusable software components. You can create new classes from existing classes and incorporate attributes and behaviors of the existing classes. Java uses extends keyword to inherit the properties of a superclass. Superclass is the class that has already been defined, and subclass is the class that inherits the properties of its superclass. In object-oriented programming, classes have is a relationship and has a relationship. Inheritance is distinguished as is a relationship. For example, a sparrow is a bird and an eagle is a bird. These both inherit properties of bird, for example, fly property. In has a relationship, a class object has one or more objects of other classes and it is called composition. For example, a car has wheels and we use have objects of string class in our classes. It is important to remember that every object of a subclass is also an object of its superclass, but the converse is not true. Now let us see a simple example of inheritance. Object-oriented programming allows you to create a hierarchy of classes. Here, employee is a superclass and manager, programmer, and accountant are its subclasses. Employee class is created first and has general attributes and methods. Manager class is a subclass of employee in which you can add more functionality and also retain the functionality of its superclass, that is employee. Note the first line in constructor of manager class. It starts with super keyword followed by arguments inside the braces. Every constructor of subclass is responsible for constructing the data fields of its superclass. It is important to note that the call to superclass must be the first line in the constructor of subclass. If you compare the manager class with employee class, you will note that raise salary method has different implementation than raise salary method of employee class. Get name method has no definition in the manager class. This is because it is inherited from superclass employee. The print method is not defined by the manager class and it prints the information using employee superclass. You can redefine print method in manager class to print information of secretary. This program creates an object of employees class and manager class and prints their information. Polymorphism. Polymorphism is another most advanced and important feature of modern object-oriented programming languages. It allows an object to decide at runtime what method to call in the class hierarchy. This program creates 4 reference variables of animal class that are hen, rabbit, monkey, and animal. Monkey reference variable points to object of monkey class. Rabbit points to object of and hen points. When we call rabbit.eat method, it decides at runtime to call the method of rabbit class. JVM checks the reference of the object that is assigned to animal reference variable rabbit. This notation denotes that every object of subclass is also an object of its superclass. Dynamic method binding allows an object to decide at runtime what method to call in the class hierarchy. This concept is helpful when you are using inherited classes. For more details, see polymorphism in this unit. Now we will discuss inner classes. A class can contain other classes. These classes are called nested or inner classes. Inner classes are known only inside the class in which they are defined. This program illustrates this. In this program, inner class is defined in outer class. Outer class contains a private instance variable. The method inside inner class can access this instance variable directly. In main method, an object of outer class is created and the method outer private through inner is invoked using outer class object. This method creates an object of inner class and invokes the display method of inner class by using inner object. Although the display method is defined in inner class, it directly accesses the private instance string object S of outer class. Now we will learn how to create packages. Classes created so far were using same namespace that had no name. Java allows you to organize classes into packages that represent folders on your hard disk. You can create a package by simply providing package command as the first line in your program. The general form to create a package is package keyword followed by package name and terminated by a semicolon. Here, package is the name of package. Java uses local file system to store packages. Now let us see a simple example. Suppose you are working in the folder e:\java work. Then create a folder my package in this folder and save test.java in my package folder. Compile the Java file. The class file must be in my package folder now. To execute a file inside a package, the execution command is a bit different. In this case, it will look like this. Now we will discuss access protection of classes and class members in a package. This table summarizes the access to the classes and members declared as private, protected, and public. It also enlists the access when no access specifier is provided. Anything declared public can be accessed from any class. Members declared as private are not visible to outside to this class. When member has no access specifier, it is visible to subclasses and other classes inside that package. This is the default access. If you want to allow a member to be available to the classes that inherit a class, you have to declare it as protected. Now we will learn how to import a package in your program. Import statements can be used to import a user-defined package. Java's built-in packages are third-party packages. This example illustrates it. Save and compile test1 file in my package folder as already discussed. Save test2 program in e:\java work and compile it. This program uses an import statement to import test1 class from my package. It creates an object of test1 class in main method and prints the message using print method defined in test1 class. It is important to note that the class test1 should be declared public in my package. Print method should also be public, otherwise these would not be accessible in test2 class. Now we will learn interfaces. Interfaces are used to abstract the implementation details of a class. That is, you can use interfaces to specify what a class should do but not how it should do. The general form to define an interface is access specifier followed by interface name followed by block that contains methods and variables. Here access can be public. If no access specifier is used, then interface is only available to the classes inside that package only. Name of interface must be valid identifier. Here are some important things about interfaces. If a class implements an interface, it must include all the methods of that interface. An interface can be implemented by many classes. The methods declared in an interface have no body. These are abstract methods. If an interface is declared public, all methods and variables are implicitly public. A class can implement more than one interfaces. In this case, these must be separated by commas. In this part of Unit 7, we will learn about exception handling. we will learn fundamental concepts, exception types, exception handling using built-in exception handler, try and catch blocks, nested try statements, multiple catch statements. We will also learn about exception class hierarchy provided by Java. Now we will learn basic concepts of exceptions. In Java, exception is an abnormal condition that arises in a program during execution. For example, division by zero, array index out of bound exception, string index out of bound, end of file exception, file not found exception. When an exceptional condition arises, Java throws an object that represents the error condition. Exceptions can be generated by Java runtime system, or these can be manually generated by user code. Java runtime system throws an exception and disrupts the program when program code violates rules of Java language. Programmer can generate exceptions manually to tell some error condition. Java categorizes exceptions into two types. These are unchecked exceptions and checked exceptions. Unchecked exceptions are mostly derived from runtime exceptions and error classes and their subclasses. Java does not check to see whether a method handles or throws these exceptions. These are handled by default handler and thrown automatically by Java runtime system. Checked exceptions are also defined by java.lang package. These exceptions are derived from classes other than runtime exception and error class and their subclasses. These exceptions must be handled by a method. If these are not handled, then all checked exceptions that are likely to be generated by a method must be specified in its throws list. This example shows how to handle checked exception. This program contains a try and catch block inside try block at line 6. The statement generates an arithmetic error. At this line, exception is generated and thrown from try block. Any code after this line in this block will not execute, and program control is transferred to catch block that handles the arithmetic exception generated by line 6. There must be a catch or finally block for a try block. Try and catch blocks make a single unit. Catch clause handles the statements of preceding try block that is written before it. Its scope is limited to only statements of preceding try block. If you are using multiple catch statements, then their sequence is important. Now let us see this program. This code will generate compilation error. Line 7 of this program will generate an arithmetic exception. Line 9 is superclass of arithmetic exception, so it can catch exceptions of exception type and also exceptions of all its subclasses. So it can handle exception generated by line 7, making line 13 unreachable. Therefore, the program does not compile. To correct this program, simply change the sequence of catch statements by shifting block of code from line 13 to line 16 before line 9. Java has defined many exception classes in java.lang package. This package is imported in all Java programs automatically. Java categorizes exceptions into two types. These are unchecked exceptions and checked exceptions. Now let us see what is a string. String is a sequence of characters and or symbols enclosed in double quotes. Java uses objects of string class to implement strings. String and string buffer classes are defined in java.lang package that is available to all programs automatically. String class provides a number of constructors to declare string objects. Here are some commonly used string constructors. By using string default constructor, the constructor that takes an array of characters as parameter to create a string, its return type is a string. The constructor that takes string object as a parameter and its return type is string. Next constructor takes a byte array of ASCII characters as a parameter and returns string object containing these characters. Another string constructor that uses an array of ASCII characters and creates a string from index position given in startup to the position given in total characters. Now we will learn string comparison methods. String class provides several methods that can be used to compare strings or substrings. These methods are equals, equals ignore case, region matches, starts with, ends with, compare to, and relational is equal to operator. Equals method is used to compare two strings for equality. The case of strings is important because equals method is case sensitive. The second method that compares string is equals ignore case. The equals method compares string based on the value contained in the strings, while equal operator is used to check whether two string objects refer to same string object in memory. In addition to comparing string for equality, sometimes it is necessary to see whether a string is less than or greater than another string. String class defines compare to method for this purpose. This method compares two strings and returns an integer value. This table shows the interpretation of value returned by compare to method. Here, when S1 is compared with S2, an integer value is returned. If the value is less than 0, that is negative, then the string S1 is less than S2. If the value is 0, then S1 and S2 are equal. If the value of return integer is greater than 0, then S1 is greater than S2. This program sorts an array of string in alphabetical order and illustrates the use of compare to method. This program compares ASCII values of strings. You can use mixed case strings and use compare to ignore case method to compare strings. Now we will discuss operations that can be performed on strings. String class allows a number of string operations on string objects. Some of these operations are string length and special string operations like comparing strings, searching strings, concatenating strings with other strings or other data types, and string modification. String class defines length method that can be applied on string objects to calculate the length of string. Sometimes you need to extract only a part of large string literal. Java provides different methods to complete this. The methods defined for this purpose are char@, getChars, getBytes, and toCharArray. Now we will see some methods that allow you to search strings. Java provides methods to search a character or substring within a string. The methods provided by string class for this purpose are indexOf and lastIndexOf. Now we will learn another string method, that is the replace method. It can be used to replace all occurrences of a character in a string by a given character. General form of replace method is string as return type followed by original character that is to be replaced by the character given in replace parameter. Here, original means the character inside the string that is to be replaced by the character passed in replace parameter. This example shows the use of replace method. Second statement replaces all occurrence of small o with capital O. Last string modification method in our discussion is trim method. Trim method is used to remove leading and trailing blank places from the invoking string. General form of trim method is string object followed by trim method. Here is a simple example of trim method. This will remove leading and trailing blank spaces from string s, but spaces between hello and there will not be removed. Sometimes you need to change the case of a string literal. Java provides two methods to change the case of all characters to uppercase or lowercase. These methods do not affect digits and non-alphabetical characters. The general form of lowercase method is string return type followed by method name and a set of braces. These methods return a string object that contains upper or lowercase equivalent of invoking string. This program demonstrates the use of both lowercase and uppercase methods. The output contains original string, lowercase string, and uppercase string. Now we will see some methods that allow you to search strings. Java provides methods to search a character or substring within a string. The methods provided by string class for this purpose are index of and last index of. Index of method searches for first occurrence of a character or string. Last index of method searches for last occurrence of a character or a substring. The first statement creates a string s, and second statement uses index of method to search q in this string and prints the index position of q in the string, a quick brown fox. Third statement starts search in the reverse order in the string stored in S and displays the result 8, that is the position of B in this string. Now we will discuss how Java allows you to modify strings. Java strings cannot be modified once they are created. Java provides some methods that can be used to create a new copy for modified strings. These methods are substring, concat, replace, and trim. This program demonstrates the use of substring. First print statement prints string hello, that is from index position 0 to index position 5. Second print statement starts the string from index position 7 and up to end of string. Concat function can be used to join two strings. These two statements demonstrates the use of concat method. String s2 will contain 1 and 2. Plus operator can be used to achieve same result. Now we will learn another string modification method, that is the replace method. This example shows the use of replace method. Second statement replaces all occurrence of small o with capital O. Sometimes you need to change the case of a string literal. Java provides two methods to change the case of all characters to uppercase or lowercase. These methods do not affect digits and non-alphabetical characters. This program demonstrates the use of both lowercase and uppercase methods. The output contains original string, lowercase string, and uppercase string. Java allows to concatenate or join two or more strings to produce a string object. It allows only plus operator to join strings. For example, here name contains the string Ahmed and S contains his name is. The last statement prints the value stored in S. Now we will learn how to concatenate other objects with strings. When a string is concatenated with some simple data types, for example int and float, Java uses value of method defined in string class that returns a string for all simple types. When an object is concatenated with another object, value of method calls toString method on the object. The default implementation of toString method is not sufficient for objects of every class, and you may need to define toString in user-defined class to convert object into string. That is, you have to override the definition of toString method. This example shows implementation of toString method in a user-defined class. The overridden method is given in date class at line number 10. Note that toString implementation in date class returns a string that is concatenated with other string in main method. String and string buffer classes are defined in java.lang package that is available to all programs automatically. String and string buffer classes are declared final, and these cannot be used in inheritance. Now we will discuss what is graphics context. Graphic context enables you to draw graphics on your screen. We will use graphics objects to control the drawing. Graphics objects contain the methods that can be used for drawing, font manipulations, and color manipulations. Java applets use a graphics object G as an argument to manage applet graphics context. Java provides platform-independent capabilities. This is because graphics are drawn differently on different platforms like Windows and Unix. When Java is implemented on each platform, a derived class of graphics is created that actually implements all the drawing. The graphics method used to draw graphics are paint, repaint, and update. Paint method is defined in component class of Java. This is available in java.awt package. General form of paint method is paint method followed by void as return type, paint method name, and graphic class object as an argument. You have to override paint method because it does nothing by default. The paint method automatically starts when a component is displayed. If you need to call paint method, then you have to use repaint. Repaint method requests a call to update method of component class. This method clears the background of component. Update method then again calls the paint method directly. Repaint should not be overridden because it performs some system-dependent tasks. Update method takes a graphics object as an argument. It is automatically provided by the system when update is called. Now we will see what is color control in Java. Java defines color class that contains methods and color constants. This figure shows some methods and color constants. The constants are created by using red, green, and a blue component. Now we will see font control provided by Java. Java provides a font class that can be used to write text in different fonts. Font class methods and constants control the display of text. Some constants like plain, bold, italic, and the methods like getName and getFamily are defined in font class. This picture displays different fonts using font control of Java. You can draw graphics by using object of graphics2D class. Graphics2D is a subclass of graphics class. To gain access to the graphics2D capabilities, you must downcast the graphics reference passed to paint method. Java 2D API provides most advanced features of two-dimensional graphics capabilities. It includes features for processing line art, text, and images. The packages include in Java 2D API are java.awt.images, java.awt.color, and java.awt.image.renderable. Java 2D shapes include packages that allow you to create 2D shapes like thick lines, filling shapes with patterns, and drawing dashed lines. You can use java.awt.geom. Java package includes double precision ellipse 2D, rectangle 2D, round rectangle 2D, and line 2D. This figure shows some of the 2D shapes. It has a thick line, a dotted line, and a shapes with pattern. Graphical user interface consists of labels, text fields, buttons, checkboxes, combo boxes. Graphical user interface consists of labels, text fields, buttons, checkboxes, combo boxes, lists, and panels. Java.swing package allows you to create these components. Swing components are completely written in Java, and these are considered lightweight components. Swing package defines classes to create these components. JLabel component is component of graphics user interface. Java defines JLabel class that is used to create text labels that are placed on a graphics object. This screenshot shows the output generated by using JLabel class. Now we will discuss about event handling model of Java. Graphical user interfaces are event-driven, that is, they generate events when the user of the program interacts with the GUI. Some common interactions are moving the mouse, clicking a button, typing in a text field, and closing a window. To process a graphical user interface event, the programmer must perform two key tasks, that is, register the event and implement an event handler. An event listener for a GUI event is an object of a class that implements event listener interfaces from the package java.awt.event and package java.x.swing.event. Java defines classes and interfaces for handling events. These are shown in this picture. Java.lang.object class is at the top of the hierarchy, and its subclasses are event object and awt.awt event. This class has further different types of event classes. The component event class has some subclasses, and one of these classes is an input event class that has key event and mouse event classes. These handle keyboard and mouse events. Event listener interfaces helps to identify the event that has occurred. It has action listener, key listener, and a mouse listener capabilities. This output shows two screenshots. When you press the button on first screen, it will generate an event and the handler will print the message. Java defines JButton class to create buttons. This figure shows different types of buttons that are created by using JButton class. Java defines JText class to create different types of text fields. This figure shows different types of text fields created by using JText class. The general form to create text fields is also given here. Java also provides JRadioButton class to create radio buttons. This figure shows radio button example that are created by using JRadioButton class. You can create checkboxes by using built-in Java class J checkbox. This figure shows sample checkboxes created by using J checkbox class. The Java allows you to create lists and perform operations on that list. Java has defined JList class to create lists. This picture shows a list that is created using JList class. Java allows you to create multiple selection lists and perform operations on that list. For example, copy it into some other area. Java has defined JList class to create multiple selection lists. This picture shows a multiple selection list that is created using JList class. Now we will see some mouse event handling methods defined in mouse listener and mouse listener interface. The general form of these methods is given here. The mouse event handling methods include mouse pressed, mouse clicked, mouse released, and mouse exited. Mouse pressed is called when mouse button is pressed on a graphic component. Mouse clicked is called when mouse is pressed and released without moving the mouse cursor. Java provides key listener, event listener interface for handling key events. Key events are generated when keys on the keyboard are pressed and released. The class that implements key listener must provide definitions for methods: key pressed, key released, and key typed. Now we will discuss how Layout Manager helps you to arrange graphical user components on a container for presentation purposes. There are three layout managers in Java. These are Flow Layout, Border Layout, and Grid Layout. Flow Layout is the default layout for java.ewt.applet, java.ewt.panel, and javax.swing.jpanel. It places components sequentially from left to right in the order they are added. It is also possible to specify the order of the components using container add method that takes a component and integer position as argument. Border layout is default for the content panes of JFrame and other windows and JApplet. It arranges the components into 5 areas: north, south, east, west, and center. Grid layout is like a grid, and it arranges the components into rows and columns.